So Microbits and Raspberry Pis. So who am I? I am Luke Spademan. I'm a student. I'm currently in my final year of GCSEs. I'm at Luke Spademan basically everywhere, online and in real life. Last year I gave a lightning talk on how to cheat in a math test using Microbits. I made a calculator that would then send the data using the radio module to the other one so you could see each other's answers. So I needed a project to work on. And everyone loves the game of Connect 4, so I thought I'd make a game of Connect 4, but Microbits only have a 5x5 LED matrix, which makes it difficult. It doesn't really leave much room for strategy or anything, so it would need to become a game of Connect 3. So, Microbits. I was going to have two Microbits playing the game of Connect 3. They'd communicate using the radio module, and that's just an example of how you can send and receive data. A lot of people asked me when I gave my lightning talk last year how I got them to communicate. So, Raspberry Pis. So I'm going to have a third microbit listening in on all of the gameplay that's currently going on. Last year, someone, as they were leaving, gave me their microbit saying, "You'll use this more than I will," and I wouldn't be able to have made this project without it, so thank you to whoever you were. So the third microbit will send the data over serial to the Raspberry Pi, which will then display the data on an RGB LED matrix that you put on top of the Pi. Because on the microbits, there's only one color, so you can to tell the difference between the different players, it's different light intensities, which is quite difficult to tell. Then other people can see your really exciting game of Connect 3 that's going on. And that's how you send data over serial on the microbit. You just print your data and it'll send it, which is really useful. And I mentioned Tensorflow in my talk title, and I was going to have an AI play you at Connect 3, but realised with the hardware I was using it'd be very difficult. So the lessons learned part of the title is that neural networks and Raspberry Pis don't really like each other that much, especially if you want to train the neural network on the Pi. And I didn't really do enough research before I proposed my talk, but you learn. So I needed a plan of what I was going to do. So you have the two microbits playing Connect 3, and then when you update the display when it's your go, you'll also send the data over the radio, which will let your opponent see the board, the third microbit see the board, which will send it over serial to the Raspberry Pi that will then display that data. So I decided to give it a go. So the first thing I wanted to do was move the counter along the top of this screen, so you can choose which column you want to place your counter in. So here's a basic bit of code I wrote that, so whenever you press button A, it will just move the counter along by one and set the previous pixel to blank and the next pixel along to whatever color you are. But this had the main issue of the counter moved incredibly fast and you can't really choose what to do. So the solution to that was just to sleep for 250 milliseconds, which allows the recognition of the one press. And you can still hold down your finger if you want it to move along a bit faster. And then I just cleaned it up by adding a few functions. So instead of using that garbled line of code from before, you can just simply call the setBoard pixel function to set a pixel on the LED matrix. But because the display is stored as a long string, you can't reference it using XY coordinates. So I made a function that just you give it XY coordinates and it'll give you the index in that string, in the string where that thing is. And you can see the implementation there. So my boxes are a bit off because for some reason halfway through making my slides, they all just moved in weird positions. So yesterday I had to quickly fix it all. So the second step is sending the data to the other microbit. So you don't really want to be playing by yourself. It can get quite boring. So you've got the player 1 and your player 2 code. And player 1 has the function show board. And whenever he updates his own board, he'll send that data over radio to his friend. That just gets the data, updates his board, and outputs it to his LED matrix. And you can see that being used there. So step 3 is dropping the counter, because that's one of the fundamental parts of actually playing the game. You don't want to just move the counter along the top continuously for hours. You want to actually be able to drop it into the grid. So I made another function which gets the board pixel at any XY point. So then we use this fall function here. So you give it the XY coordinates of where you start and the board and the color that you are, and it will slowly make the pixel drop to the bottom, or if there's a pixel that's not blank beneath it, it will stop falling, because then you can't really play. So you can see that there, and here we're just setting the board pixel, so the pixel above you gets set to blank and the one where you're going down to you gets set to your color, and that's implemented there. So you press button A to move your counter along the top and button B to drop the counter down to the bottom, and you can see that being implemented there, and then you can drop the counter on top. Perfect. So step 4 is taking it in turns to have a go. So as I said previously, you want to have some friends to play with. So the code for the 2 people is basically the same. The only difference is the starting variables at the beginning, so whether it's your turn and your color, and 9 represents the brightest color on a microbit and 4 is fairly dim, so you have a good difference. So if it's your turn, you will do everything we just spoke about, and then once you've finished dropping the counter to the bottom, you'll send the your turn signal over the radio, and then when the other person receives that, they'll make it their turn again. So that's the only difference between the 2 bits of code there. And you can see there the difference in brightnesses allows you to tell which counter is whose. So step 5 is stop players from placing counters on the top row, because that's just being reserved for choosing where you want to place your counter. So we simply just put in a while loop there. So we're saying while the counter beneath where you're going has something there, move along another one. And here we just create a list just full of blank characters, which will be the rest of the top row, and we have a for loop just to implement that. And in case some of you didn't know, you can use enumerate to get a counter in your for loop, so those 2 bits at the bottom are the same, so it saves a bit of line space, which is really useful, because I kept on having the issue with my microbits that my code was too big to actually go on the microbit, so I had to remove loads of blank lines and comments and things, which makes people very angry, but the code will actually work, so I think it's a good price to pay. And you can see that it will just skip that column when you press the button, it just skips straight over it. So step 6 is sending the data to the Raspberry Pi, because as you saw earlier, it's incredibly difficult to see what's going on, so having another display is great, and other people can see your competitive games of Connect 3. So the 3rd microbit literally just listens to all the radio communications, and if the communication isn't the your turn signal that's being sent, it will just send that information to the Raspberry Pi. So first of all, we need to import serial on the Raspberry Pi and import the SenseHat module that just allows you to send the data to the LED RGB matrix. This bit of code here I copied from the Raspberry Pi Foundation website, because I didn't know all of the settings I needed to allow the Raspberry Pi to get the data from serial from the microbit, but that's the only bit I copied there. And then here I just show a tilde on the RGB LED matrix, so I know that the program has loaded properly and I haven't had any issues setting up the serial connection. So this is before any actual useful information is displayed. And then we just set the colors for the first player, the second player. Blank is just where no counters are placed yet, and we need the edge because the LED matrix on the Raspberry Pi is 8x8 as opposed to the 5x5 on the microbit, so we'll just have edge characters around the outside so you can see what's actually part of the game. So then we have a loop, and inside there we get the data from serial, and then we split it at every colon, which is each new line. So the for I in range of 8 times 2 is just for 8 is the length of each row on the LED matrix, and 2 is for the top 2 rows. They're just going to be the edge, so we'll add those on. And then here we're saying if the value is 4, we're going to give it player 2's color. If it's a 9, we give it player 1's color, and if it's 0, we give it blank. And then we have 2 thick edge on the right hand side, and then we just have 1 layer of edge at the bottom of the screen. And we then send those pixels to the sensor, and that can be seen there. That screenshot is taken from trinket.io, which gives you a virtual Raspberry Pi with a sensor that you can play with, which is really useful. So I didn't have to find my Raspberry Pi every time I wanted to change some of my code. So next you need to detect when you actually win the game, because there's no point playing, because often in these games I notice people don't notice when they've won, because they're unobservant fools. So we just need to split the display into rows, and that will give us a data structure thing that will look like that. So we need to detect a win in a row. That's the first type of win we're going to try and detect. So we're just going to go down each row and look at the first 3 pixels, and if it is of a player's colour, we're going to look across and another 2 pixels and see if they're all the same, and if they are, that means someone's won, and we'll return the colour of the winner so we can congratulate them properly. So here you can see an example win in that list and on the sensor. And so it will go down each row, and then it will check in those places. So now we need to detect a win in a column, which was slightly more difficult, but not much. So we go down the first 3 columns and along everything in that row. There's an example win that you could have. So we go down each row and look down by 2 more columns to see if they're all the same. So we'll be checking down like that to see if they're all the same. And now we need to check if they won on the y equals minus x plus c diagonal. I didn't really know how else to describe it, but that's what the win would look like on the sense hat, just a diagonal in the wrong direction to what you normally see. So we just go along in the range of 3 and the range of 3 again, but this time we go up in the column and the row when we're checking in the diagonal. So you can see it will check down like that. So you're increasing your x and your y coordinate, and it will go across. So now we need to check in the diagonal that's flipped the other direction. This was by far the most difficult, but wasn't too difficult. So that first range just goes from the last box up to the middle one, and then we do the same thing as before, going along that diagonal. So it will just look along like that and check to see if you won. And then again, it will return your colour. So then just an overview of everything we just did. You've got the detect win in the 4 different places. But then if you don't win, we just need to return none, so you know something's happening. And then I can edit what that returns later if I need to, when I further develop my code. And then we need to implement the win detection, because that function actually has to be used somewhere. So, oh, no, I didn't want to do that. So once you've dropped your counter to the bottom of the screen, we're just going to make the winner variable equal to whoever won. And if you won, we'll congratulate you. And if you didn't, we'll just send your turn signal like we did before. And then at the bottom of the code, you can see if you received that I won signal, you're on your defeat code. But we'll come to how that's sent in a minute. So here, we're just in the congratulate code, we're going to send the I win signal so the opponent knows that they lost. We're going to display a happy face and play that happy sound using the music library, and then defeat shows a sad face in a really sad tune. So finally, you need to end the game once you've won or once you've lost. So here we just simply add a break under the congratulating defeat code. So if you've won or lost, then it will just end the code nicely. So that's all I've done on that code so far. I'm hopefully going to add to it and change stuff later on. So what have I learned? First of all, you shouldn't be confined by what people say a device can do. People wouldn't necessarily say that you use another microbit. It doesn't have any functionality apart from just sending data off to the Raspberry Pi. And then if you have an issue, search the web. I didn't know how all the settings for receiving the data from serial between the microbit and the Raspberry Pi, so I just gave it a quick search and I found that the Raspberry Pi Foundation had a great answer for that in some of their resources. And I know that Python programmers are really nice. You guys have been great. Thank you. So thanks for listening. My code is available on my GitHub. I am Luke Spademan basically everywhere. And I'm here until Sunday in case you have any questions, and I can take some more now if you want to. Thank you.
Speak up as well, just because the microphone's picking up. And over to you.
Yeah. Do you have the equipment here with you? Can we see it?
Yeah. Hopefully it will work.
Have you made a sacrifice to the demo jobs?
Where's my power? I'll just power it from here. Oh no, that's the wrong thing.
While you're setting that up, how long this project took you to do from beginning to end?
Well, it took a long time because I didn't work on it for ages because school got in the way. So I actually started it at PyCon last year and got I got it basically working, but then I didn't work on it for ages until like last week. And then and then I added the extra functionality with the Raspberry Pi and actually detecting if you've won and things like that.
It took about a week.
Yeah. Turn these on.
I have a question.
Yeah.
If I have a microbit and I tune it to channel 27 and I get it to spam the letters IW, do I break the game or?
It's not channel 27. There's probably a thing I need to add later to verify things. But Raspberry microbits don't actually, from what I've seen, have a way of uniquely identifying themselves. So with MicroPython, you've got no access to anything like a MAC address. So I was thinking I might just make them generate random numbers that will then identify them later on, and then they can both run the same bit of code and see whose random number's bigger, and then they'll be player one or whatever. But that has not been done yet. So this is just displaying the tilde because it's loaded. I think that's the right way around. So press button A and the yeah. Oh, don't want to hold it, Dad. There you go. It's not. Don't hold my laptop.
Useful this for the conference.
Do you want to hold the laptop as well because it's like small. So you can see
on the front.
You can you see that? And then so when you press button A on the it's upside down.
Oh.
There you go. So you press button A, it will slowly move it along the top, and then when you want to drop it in a position, you just press button B, and you can see it falling down. Then it switches to the other person's turn, and they can move. And I'll just quickly make someone win because then you can actually see interesting things happening. Oh, I didn't mean to drop that there. Oh no, okay. They can just win there. And then when this person wins, he has a happy face and he has a sad face. Yes?
Any ideas for games to implement in the future?
I was thinking I could make a snake-based thing. Because in Snake, you actually only have two options of your next control. You can go left from your current position or right. So you could do that on the microbit. But I was thinking with this, I could get it so you can change the colour for each player because the sensor has a little joystick. So you could just have 2 pixels dedicated in the top edge that you can use for changing things. I've had quite a few ideas, just not a chance to actually implement them because doing GCSEs takes up a lot of your time. Yes?
Sorry, I had a question which was to do with, you mentioned at school the gospel of lightning. Have you thought of submitting this for a school project, or is this just a sideline?
It's currently just a sideline thing, but when I do A-level computer science, your coursework can be literally anything you want. You just need to have someone that you're making something for. So I could potentially make something like this for that, but I haven't really thought about it yet. Yes?
Frivolous question and a real question that should be quite easy. Have you got a better name for the 2 players than Bright and Dim?
I'm always player 1, so I'm Bright. Well, I think it's like 2024 bytes. So, yeah, it's not that much, but you can make it work. But I think you can get round that by just having a small amount of actual code, but then loading files on separately that it imports stuff from. But there's still not much storage on a microbit, so it's still not too doable. And these microbits have a little board on the back with a battery and a speakery, buzzery thing. So it makes it more portable, so I don't actually have to plug it into anything, which is useful. Yes? It's called a My Power Board from kitronic.co.uk. But I don't know where I got it from, somewhere online that sold it. Yes?
Have you taught anybody in your school about anything
I don't think so. Anyone else? Awkward silences are great, aren't they? I don't know. Oh, in school, so the Raspberry Pi Foundation have a Pioneers competition thing. So I'm in a group with people and we're going to be making a really bad smartwatch thing, just with an LCD screen and a Pi Zero W, which will be fun. Don't know why that was important to mention, Dad, but...
Okay, well, fantastic talk. Seriously, thank you very much.
Thank you.